Hi, everyone. My name is Dan Ferrante. I'm Director of Platform Engineering at Digital Turbine, and thank you for the honor of talking to you today. I wanted to discuss a case study that we did, or a proof of concept that we did with Delta Lake, with Databricks, using Delta Lake and Spark Streaming. So the agenda that I have today is basically going to give you a brief overview of what Digital Turbine is, where we've been in terms of the state of data architecture, kind of the background of and current state of events, where we're headed, also what our current objectives are as a data engineering organization, and to talk to you about the proof of concept that we did with Databricks, pretty much the why, the what, the results, and finally the solution. And in the end, give you an idea of what the Delta worldview at Digital Turbine is, and what's in the works or future projects for us. So what we do, I like to use 3 verbs to describe it. So we simplify, discover, and deliver. So by simplify, I mean Digital Turbine provides an ecosystem for delivering apps to end users' mobile devices, while also providing insights to advertisers, carriers, and OEMs related to those apps. In Discover, we own the platform, enabling end users to select and install applications they want in a first-time mobile experience, while also delivering up-to-date information about those apps, news-related information, and in-life experiences like games folders and single-tap installation. And finally, our mantra at Digital Turbine is to deliver. Digital Turbine delivers the right app to the right user at the right time. So just to talk a little bit about where we've been from a server architecture. Basically, in the past, we've been using semi-structured data and been storing that right into Redshift. So we stored raw event data in Redshift, broken down by partner for 2 years. The data growth, along with the requirements for more data faster, has essentially slowed our Redshift cluster, so we've had to scale up several times to reduce the burden. We had a kind of difficult to maintain architecture for our operations team, so we were struggling to maintain and manage an architecture contain mostly self-managed clusters, from Apache Storm to legacy versions of Kafka. So really the goal is to standardize and thrive, not just survive. And finally, thirdly, definition, which I call ETL of the Month Club. So there will be a quiz at the end of the class. No, just kidding. The process of trying new ETL technologies and switching while keeping older technologies in production. So we really need to get out from under the different ETL approaches and standardize on 1 or 2. And finally, just looking at the batch ETLs with no real-time support. So delivering real-time data wasn't possible with our legacy event mechanism. So the Apache Kafka and Storm support we did have was outdated and in need of updating. So that illustrates a bit of the challenges that we faced. This is kind of a demonstration of the challenges. So we have this great mobile client that sits up front. We have Redshift that's being used for reports, as you can see in the back. We had a bit of Spark, but we had a lot of various things that we were working on and trying. So microservices, new versions of Kafka, homegrown ETLs, third-party ETLs, putting data in S3 using Storm and Kafka 8. And what we needed was to organize this in such a way and figure out what worked best for us. And that's partly what we did in this proof of concept. So to give you a background on the data sources and stores that we have here at Digital Turbine, we have 4 data sources. So that's data that is coming into our stores. And we have 3 stores that I like to, or 3 different environments that I like to call stores. So the first data source is targeting and campaign slowly changing dimensions. So these are configuration settings that are being pulled from data sets from our various RDBMS databases, every hour. We also have a new set of data we call Unified Mobile Events Pipeline, which are also known as, you'll hear me refer to these as U events in future slides. So these are next generation logging events sourced directly from the digital Turbine mobile platform, so directly from the client. Campaign events pipeline, so a subset of revenue impacting events such as app install or app open mobile events. And finally, legacy mobile events. So these represent events from our legacy mobile clients, so older versions that are not being stored to a data lake, they're being directly stored into Redshift. And then finally, to talk a little bit about the stores that we have. So where everything is stored, we're using Delta, Redshift, and Datadog. So to give a little more background on the data flow rate that we face and the challenge here. So 180 million events per day flow through digital Turbine data systems. That excludes the slowly changing dimensions. The unified mobile events pipeline delivers about 134 million, so 75%, around 75% of that. Those are debug level events that go directly into the data lake and Redshift temporarily for business intelligence analysis on a regional and partner basis. The campaign events, which represent about 7 million or 3% of our events, those are revenue events that are delivered to the lake and then aggregated by Spark and written to Redshift for revenue reports. So the aggregations are actually written into Redshift, which we're calling facts. And finally, legacy mobile events, their pipeline, it delivers 41 million events per day still into Redshift via Talend ETLs. These are clients that are delivering older structure of data into Redshift, into temporary MySQL database, which is being delivered to Redshift via Talend. Our current objectives. So one was real-time, taking advantage of streaming data from Kafka for real-time event observation and monitoring, retire legacy real-time technologies such as Apache Storm. And we performed a POC in partnership with Databricks in May and June of 2020 to test Spark streaming and Delta Lake capabilities. So dealing in best practices is another objective. Offload the raw semi-structured event data from Redshift to S3 using Delta as a layer above S3 and Parquet. So we want to use Redshift as a primary repository for data aggregations and data marts, but not so much as a repository for raw data. And so the S3 Delta layer becomes the repository for ad hoc queries and sources the aggregations and data marts. And finally, standardizing ETL technologies. So this results in data that is what I call accurate. So any data fluctuations taken in the system can be both good and bad, but fluctuations happen. They need to be based on external events and not on issues with the data itself. We want the data to be precise, and we feel that standardizing these technologies will help the data to be precise and also reliable. So errors in the pipeline are quickly identified and require an incident and a quick response. And by reliable, we also want these events to be ACID compliant. So Delta helps us get to ACID compliance by enabling a database layer above our Parquet, our files that are stored in S3 in Parquet format. So I want to go over the POC, or the proof of concept, that we performed with Databricks. So the why, the reasons for running the POC. We had Storm retirement on the mind, so we wanted to prove out a streaming strategy to replace Storm and introduce real-time data monitoring. So Storm is run on a cluster managed by digital Turbine employees, and it requires specific expertise to maintain it. It's also justifying spend. So delivering facts to justify the spend and estimate the Redshift plus Storm savings. So we want to utilize S3 as a backbone for data analysis and investigatory studies. This represents long-term cost savings if we're not storing that data within Redshift. We're storing it within S3, which is a less expensive solution compared to Redshift. And finally, Databricks is managed and supported. So we can justify spend on these managed clusters because these systems are managed and well maintained and supported. In other words, we want to spend money on things that we do best, and we want to encourage using technologies where other companies are doing are using their specialties, performing their specialties. And finally, event recognition. So we want to have facts to show improvement on revenue recognition and business impact. So moving from batch to real-time campaign event rollups, and then finally real-time event monitoring. So the what? So what did we measure with the POC? Well, we looked at several different measurements, and three of which here I've limited these to three for the sake of this conversation, but one is system availability, so 99.9 up to 99.99, 49% to start. Data, so time to market. So we wanted to see new events available for ad hoc querying every few seconds. And then finally, communication. We want to see alerts and monitoring set up with dashboards for our operations team. So the results of the POC and what did we learn and what did we get out of this? So system availability. Over the past 2 months, we achieved 4 nines availability. So we really had an hour estimated downtime in 2 months on streams. And this occurred, the 4 nines was capable because of several factors. Databricks managed the Spark availability and uptime. Spark structured streaming features are mature. Both the micro batching, continuous triggers both hold up well in high load environments. Optimizations with the help of Databricks support on our streams. Modularized code, so it's the same code base for many streaming jobs. Job resiliency, so if a cluster fails, the job should restart itself. But also items for Delta, such as write optimizations, how to improve and optimize the data itself within S3 so that it's optimized for Spark to read that in. So secondly, we looked at data time to market. So our highest load partners handling about 300 to 500 events per second. But we have multiple partners streaming data on individual cluster to give an idea of scale. Delta is loading every event, and we're running hourly queries against Delta tables to verify the event counts are consistent. And finally, communication. So this is a graph that I actually love to show in this case. The following graph illustrates our ability to track a particular event, a particular client failure event in real time with Spark Streaming and Datadog. So as you can see, we've been tracking what that failure event, what's happening with that failure event. And you'll notice that here it goes out of the anomaly detection system. This is exactly the point where our client was fixed. And so you can see that the amount of data coming in lessens at that point. And over the past 2 months, it stayed low, almost to zero for that. So our stream in correlation with Datadog immediately detected the lower rate of failures and let us know that the problem was resolved. So to talk about the solution that we came up with, just the streaming and data lake architecture. So what I've got here is a diagram, an architecture diagram that's showing the future state, some future state, the current up-to-date pieces, and then pieces that are in progress. So here we have the mobile user connecting with their Ignite mobile platform. and it's downloaded apps, and we're logging information to our microservices API, which is publishing information out to Kafka. Now, I've written this as future state because we're in the process of transforming or moving our Kafka clusters away from being self-managed to using the new Kafka MSK solution. So we have Kafka MSK, and we also have currently, which is current up to date, a variety of streams that are streaming that data off of Kafka MSK using Spark streaming. Each region has its own stream essentially, and we have multiple partners that are running within each region. What these streams are doing is they're sending monitoring information to Datadog, but they're also sending inserts into the Delta Lake that we have. They're writing inserts into the Delta Lake. And at the same time, Tableau is going to be starting in the next several months. They're going to be starting to use the Delta Lake as a primary means for ad hoc queries and reports. Whereas currently they're utilizing our Atlas cluster, which is the Redshift cluster that we use for raw data. So also to talk about just how we broke up the Delta Lake into a variety of tables and what we felt were best practices for us. The U events, or the unified mobile logging events that I have at the top, are basically partitioned by partner name, year, month, day, and hour. And the actual table name is the region that data resides in. So you can see that underneath that, we have a variety of fields available, such as DTID, which is a generated unique identifier by our team, a digital turbine ID. We have an event GUID, which uniquely identifies the event. Also timestamp information, a variety of debugging fields, which can be up to 100 different fields, campaign ID, and site IDs. So you can see that each of these is broken up by region. And then we also are utilizing additional streams for inserting preloads, clicks, installs, and get ads requests into our Delta Lake as well. So with this, it provides our TAMs and our operations teams the ability to quickly query data without having to connect to a database, but be able to utilize this data that comes in real time and essentially allows us to view and understand information about the system. So to talk about how Spark structured streaming in Delta is in use today. So we're streaming events from mobile devices to microservices to Kafka to Spark structured streaming, and finally to Delta Lake and Datadog. And with that, we're delivering real-time KPI dashboards, ad hoc querying capability within notebooks, fast transformations using Spark, and managed Spark clusters. And you can see over here that this is an example of a notebook that we're using to track a variety of different events that are occurring within the system. So what's the view of Delta and Databricks at Digital Turbine? We're very excited. Data is now more readily accessible to technical account managers and business intelligence team members. It was previously difficult to access. The time to pull the data is faster because we can do the following. We can dedicate a team cluster to each of the various teams and provide them access. We auto-optimize on writes, which helps to continuously optimize the size of the S3 Parquet files. Users can access a variety of notebooks, and many of which we've set up templates for them. So their teams have created various notebooks based on these templates. And we can join tables using Delta Lake, legacy data in S3, and Redshift dimensions with Spark. Also, designing, planning, and delivering our Delta and streaming solution was accomplished in 1 month in partnership with the Databricks team. So in the works are future projects. We're looking at Redshift optimization, which is in the works. Our Redshift clusters currently contain the raw data associated with pipelines mentioned previously. We're moving that data out to a data lake with Delta on top, sitting on top. Business metrics and data wellness report. So it's a report that's intended to show the status of business KPIs in a straightforward, understandable manner. It's intended as a set of C-level reports to show business health, as well as data health. Looking at cost optimization and data quality reports. So we're understanding and controlling where costs are centered and detailing that information in executive level reports. So that's in the design phase now. We're thinking about it. We're trying to understand what we need to do. And finally, for the future, looking at machine learning algorithms or creating traffic and targeting algorithms to better anticipate how devices work. And also data generation tools. So using Spark as a means for generating large-scale testing data sets for better simulating our mobile traffic through a staging environment. And finally, I want to invite people and have a call to action to come join us at Digital Turbine. So I wrote the top 5 reasons for joining Digital Turbine. You like working on large-scale projects that are using best-of-breed technologies. You love working with a great group of people across the world in Austin, Mexico City, Durham, Tel Aviv, India, London, California, etc. You want to expand your experience in Android tech, Spark, Scala, Java, Elixir, Python. Out-of-the-box thinking is not only encouraged, it's the norm. And best of all, you want a place where you can make an impact. I want to open it up, and please feel free to reach out to me at my email address there. And you can also seek out any available positions at our Digital Turbine website, our careers website. So I want to thank you for your time today, and I appreciate the chance to get to discuss what we've done at Digital Turbine with you. Thank you.